All right, so first thing, this is kind of like extra credit also. Remember I just showed you the answers are not in the back, but they're on Google Classroom because I'm trying to save paper, from pages 16 to 22. So the answers are on Google Classroom, but because I'm showing you all the answers, make sure that you show work to get credit for it. Show work, and it's a classwork grade. So it's an easy classwork grade if you show work. Otherwise, it may end up being a 70 or less, whatever it is. Okay? All right. So to start with, this says find the exact values of the 6 trig functions and do not use a calculator. So you've got -7 pi fourths. So what we did for this one is we used your unit circle. And so for -7 pi fourths, you go to where the positive one is, and then reflect the x-axis, and so you're where pi fourths is. On the test, I saw some people try to go to this side, but you just want to go straight up. So go to where pi fourths is, and that's square root of 2 over 2. So reflect the x-axis. And at pi fourths, it's square root of 2 over 2 for both. The other way to do it is to take your -7 fourths and add 2. -7 fourths plus 2, that gives you 1/4. And so then you get pi fourths for the coterminal. Coterminal means where it's equivalent. So basically, if you go backwards 7 pi fourths, that'd be like start here, 1, 2, 3, 4, 5, 6, 7, backwards 7 pi fourths. Or the easier way is to just go to 7 pi fourths and then reflect across the x-axis. The other way is to even just change it to degrees. So you could say -7 times 180 over 4. So that's -7 times 45. Lots of different ways to do these. And so you get -315. And then you go 360 minus 315 and you get 45. So all that to say, you should end up with this ordered pair. Square root of 2 over 2 for both x and y. Any questions on how you get there? Okay, so then remember your definition for sine is y. And so that's square root of 2 over 2. Your definition for cosine is x, and so that's square root of 2 over 2. For tangent, it's y divided by x. So if you're dividing the same thing, you should get 1. Remember, for tangent, in this quadrant, which is quadrant 1, and this quadrant, which is quadrant 3, you should get 1. For your tangent, for the one with the pi fourths reference, or 45-degree reference, because this is the negative of both of them, so negative divided by negative is +1. Any questions? Okay, so then for cosecant, you flip your sine answer. Remember that the C and the S go together for inverses, and that's in your notes. So you basically flip your first answer. So you have 2 over square root of 2, and it tells you to rationalize your denominators. So you get square root of 2 over square root of 2 because you're multiplying by 1. The main idea is you got a square root of 2 here, so you got to put it on top and bottom, and then multiply straight across. So 2 times square root of 2 is 2 square root of 2, and square root of 2 times square root of 2 is square root of 4, which is the same thing as 2. This is what some people put on the test, and I went in and checked, and if you got that, I counted it right. What you're supposed to do is simplify your square roots. And so basically, your 2's should cancel. So you should just end up with square root of 2. So I went into all y'all's tests, and if you put an equivalent square root, I put that. So as a random example of that, what I did on the test, some people got square root of 18 over 3, and that should have been like square root of 9 times square root of 2 over 3. So 3 square root of 2 over 3, and then eventually square root of 2. So if somebody had this, it should have been square root of 2, but I counted it right.
Okay. I remember I asked you about that, no, those, because it was like 49 over 7. Something like that. And you're like, oh, I guess.
Yeah, some of them you can, some you can't. Yeah. This one you have square root of 18 over 6, and so that would have gone to square root of 2 over 2. Do you want me to show the breakdown of that one also? Okay. So those are just random examples. So I gave you all credit on the simplifying square root. But make sure you all follow the directions on here about getting an integer or fraction, because it doesn't want any decimal answers. Okay, so then for secant, your definition is with the cosine, 1 over cosine. So again, flip 2 over square root of 2. And since we already did that, it's the same answer. Now, the thing to remember is, if this one were negative, then you'd have to have a negative down here. But in our case, we have both of them positive, and so both of these are positive. Because remember, when we did our unit circle, if you're in quadrant 1, all of them are positive. Sine, cosine, tangent, cosecant, secant, and cotangent. All of them are positive in this one. And then for cotangent, that's 1 over tangent. And so we're flipping 1, and so we still get 1. Any questions? Okay. The next one, it says find the exact value, which means you're going to want to use your unit circle. It says do not use a calculator, but you can use one to know what number to go towards, and then check your answer. So let's do that first. The first thing is, if it has pi in it, then make sure you're using radians, not degrees. Use radians, not degrees. So on your scratch pad, if you're in degrees, then just single click it. Now I'm in radians. Okay? And then type it, so 6. Then you press the trig button, which has your menu, and we have sine. Then it says pi. So use the pi button, which is to the left of the H. And it's right there, so push enter. Over 3. Then you need to go to the right to not be inside the parentheses anymore. So we have 6 sine pi over 3 minus 6. Then we go to tangent, so go trig, go to tangent, then pi, divide by 4. So on this, your decimal that you're working towards is this. The decimal is negative 0.80 3, 8, something. Okay, so we want to use our unit circle, get our answer, and compare it to this. That's how we know we got the problem right. So the first thing is, for pi thirds, on your unit circle, that ordered pair is 1/2 comma square root of 3 over 2. And so when we're doing sine of that, that's the y answer. Because remember, an xy ordered pair is like cosine comma sine. So that means we have 6 times square root of 3 over 2. Because we have the 6, we bring it down. And the sine of pi thirds is the square root of 3 over 2. The other part has pi fourths. And so that ordered pair on your unit circle has the square root of 2 over 2 for both x and y. Yeah, exactly right. So for tangent, that's going to be 1 because it's y over x. So then we fill in this minus 6 times 1. Now, we need to simplify that. We do 6 divided by 2, which is 3. So we get 3 square root of 3 minus 6, and that's your answer. And then we can check it. 3 square root of 3 minus 6. I got the exact same decimal.
Where do you get like 3 square root?
Oh, because 6 divided by 2 is 3, and you don't mess with the square root.
Okay.
You're welcome.
6 divided by 2 is 3, yeah.
Yeah, 6 divided by 2 is 3. It's like 6 times a half, and then you just put square root of 3 there. Yes.
Is our exam going to be on that exam?
Yes, it will. Yeah, good question. Okay, good. Any other questions? Okay, now number 3, this one's 300 degrees. So the easiest way is look at your unit circle, and 300 degrees says the radian would be 5 pi thirds. So that's the easiest way to do it, as long as the number shows up. The other way is to use your conversion, which basically involves multiplying by pi over 180. When you're going to radians, your pi has to be on top. So on your calculator, you basically do 300 divided by 180. .300 divided by 180, enter, it's 5 thirds. So that's how you simplify your fraction. And then after that, you write pi after it like we did here. So it's 5 pi thirds. So 300 degrees is 5 pi thirds. Any questions? Okay, number 4, you have a 6-degree polynomial. It tells you the coefficients are real numbers, and it wants to find the remaining zeros. So basically on this one, this is about the conjugate pairs theorem, which basically means if you have negative 7 plus I, then you should change the sign of the I term. If it's positive, then make it negative. And then this one, for the negative I, you make that plus I. So 4 plus I. So we've got negative 7 minus I and 4 plus I. Don't change the sign of the number in front. Like, don't change this -7 to be +7. Just change the I to -I. So this was in chapter 4. Any questions? Okay, now this tells you a specific point that's on the unit circle. If it tells you this, then you don't need to use the chart, because it won't show up. The -√3/4 doesn't show up anywhere here. Don't use the chart, just trust it. So you've got x, y, so that's cosine, sine. So your sine would be the square root of 13/4. And your cosine would be -√3/4. Any questions on that part? Okay, then for tangent, you're doing y divided by x. So your 4's cancel. You are going to end up with a negative, and it's square root of 13 over square root of 3. And then you're going to want to rationalize the denominator. What we mean is multiply by 1 in the form of the denominator part, which was square root of 3 over square root of 3. So basically you look at your denominator, which is square root of 3, and put it on top and bottom, because you need an equivalent number, and you can always multiply by 1. So what we're doing is we're going to multiply straight across. Negative square root of 3 times square root of negative square root of 13 times square root of 3 is negative square root of 39. So when you see them next to each other, then multiply. Then you do square root of 3 times square root of 3, which is square root of 9, or just put 3. And that's your answer. That's it. Yeah, because this one, you can't say 9 times anything, or 4 times anything, or 16 times anything to break it down. Then for cosecant, it's 1 over sine. Remember, sometimes on Math Excel they put cotangent forth instead of cosecant, so they just got to have you pay attention. But in this case, they put cosecant next. So flip this answer. So we got 4 over square root of 13. And then rationalize it like we did this one. So we put square root of 13 over square root of 13 because we had the square root of 13 there. Then multiply straight across. 4 square root of 13 over 13. That's your answer. Then for secant, it's 1 over cosine. So we flip this answer, so you get negative 4 over square root of 3. Flipping is the same thing as calling it the reciprocal. Now don't confuse that with opposite reciprocal where you change signs. We want to preserve the sign, meaning if this is negative, so is this. For your cosine and secant, they have to be the same. Positive or negative. Okay, then let's rationalize. So we get negative 4 square root of 3 over 3. And then for cotangent, this is like 1 over tangent. So flip this one or flip this one. It's easier to flip the first. I guess I could show it both ways. Negative square root of 3 over square root of 13, and then rationalize that. So you get negative square root of 39 over 13. So that's one way to do it. Or if you flip your final answer, you'd have 3 over square root of 39. Then rationalize that. So you get negative 3 square root of 39 over 39. Now the problem with this is Math Excel would count that wrong because 3 does go into 39. This is what I ended up counting right on your test. I went through all the tests and saw. But if you have 3 over 39, that should reduce to 1/13. So,
It would be 39.
yeah. So the 3's basically cancel.
So it'd just be okay.
So it'd be that. So negative square root of 39 over 13. Yeah, which is equivalent to that. So you can do it either way. Any questions? All right. Number 6. This tells you about x squared plus 2 with it just being to the right and including 0 in order to make it 1-to-1. So the graph of this looks like that. If you want to, you can graph that on the calculator. So you go graph, and then you put x squared plus 2, enter. Now when you graph it, you see both sides, but then you got to think, oh, it's x greater than or equal to 2, and so, 0. So then you just cover up that side. That's the easiest way. A more complicated way is if you go into here, and then you make it like specify to only graph the right side, but that's a little complicated to do. It would look like this. So you go to your piecewise, and this, and this would be x squared plus 2. The thing to the right of the comma is your condition. So your condition would be x greater than or equal to 0. So you can put an x here. Then you see all your inequalities here, so you can do control equal. And I want greater than or equal to 0. Now if I push enter, it may not like that I'm trying to get 2 parts, but that's how it would look. Yeah, it says syntax error. Let me just put something random for this. Okay, so if you ignore the bottom line, which would just be the ordered pair 0, 0, the x squared plus 2 looks like that, which is what we did. Again, the easy way is just cover it up with your hand and don't use piecewise. Right? Okay, so we know about that. Now, it's talking about the inverse, and so that means switch x and y. Switch x and y. So we're starting with f of x, which is what y is. So you have y equal x squared plus 2, and then switch it to be x equal y squared plus 2. What's that?
Nothing.
Okay. This was in chapter 5. Yeah. So then we want to subtract 2 from both sides. And then take the square root of y squared and take the square root of this. And really when you take your square root, it should be plus and minus, but because this is limited to positive, then so is this. So use your square root of x minus 2. So now if I go back to what I was doing earlier, and I change this to what we really wanted, we'd have the square root of x minus 2, and we want this when x is greater than or equal to 0 also. Well, that didn't show up. Let me start over on that. It's probably because both have x. So if we just do square root of x minus 2, that means it's going to go to the right 2, which looks like that. And then you just put the graphs together. It's not B because that has both pieces, and same reason for C. It'd be the one that goes up with to the right. This one has them crisscross, which they don't do, so it's D. Okay, so we've got the graph part, and then the square root of x minus 2 goes right here, because that was our inverse. Remember, once we solve for y, that's f negative 1, which is your inverse. And again, because this was positive, we just want the positive for this one. All right. Any questions? Okay, this one says change the exponential to an equivalent with logarithm. And so if you see E, if you have E, then do ln to both sides. The easiest way to remember that is E and ln share the same button. You got to do Control E to the x to get to the ln. Just like 10 to the x and log share a button. So that means we're going to do ln of e to the x equal ln of 22. So your ln and e cancel because they're inverses, and so you just get x equal ln 22. That's your answer. Yeah, ln and e cancel because they're inverses. I would remind y'all, this does say write an equation, and so you need something equals. Don't just put ln 22 for your answer. Make sure you put x equal. Any questions? Okay, now this one, number 8, says find the intercepts. When we're finding the x-intercept, you set your numerator equal to 0. For your vertical asymptote and for your domain, you'd set your denominator equal to 0. I just put D to abbreviate. We're not doing that for the denominator. We want the intercepts, so we're going to find the x ones by setting the numerator equal to 0. So we go x squared minus 25 equals 0. Add 25 to both sides, and then take your square root, so you get plus and minus 5. So that's 2 of your answers. It says ordered pairs, so we do want that. Or if you'd rather write it negative 5, 0, and 5, 0, you can. Don't forget the y-intercept. Also the y-intercept. So the easiest way to get the y-intercept is to type the function and then look at your table. So if we go parentheses x squared minus 25, remember the reason we need the parentheses is because all of that goes on top. Then go to the right, and then all of the x squared minus 16 goes on bottom. So that over that. Double check how you typed it to make sure it looks right, and it does. These would be your vertical asymptotes at the plus and minus 4, and then the x-intercepts would be at plus and minus 5. Remember, we can go to that from Control T, because table, and at 4 it's undefined, but at 5 it's 0. So that's one of them. And then we just go up. At negative 4 it's undefined, but at negative 5 it's 0. Okay, so at this point all we did was confirm these answers. Then we also go to where x is 0 and we get this, 1.5625. That's our y-intercept. Now the directions say to use integers or fractions. It's not an integer because it's not a positive or negative whole number. So you can either type this in and convert it to a fraction or copy and paste. Yeah, so from the table you can do Control C. Then go to on, then calculate, then Control V. So you can copy paste and then go to number and then to fraction. So you get 25/16. If you didn't want to copy paste, then just type it over yourself. 1.5625 menu number fraction. Right. So that was menu number fraction. And so that's our other answer. But this case was 0, that. So these three, or you could say, this group with plus and minus 5, or this group with them separate.
Would it take either one of the answers?
Yes, it will. I'll make sure it does. Yeah. Yeah, this is a type thing where if you use your plus and minus button, and if for some reason it counts it wrong, I'll make sure it's right. Yeah. Okay. Any other questions? Okay, now this one, you're doing composite functions, so this was in section 5.2. F circle G of 4. What that means is F of G of 4. So the first thing you do is your right side, do G of 4 first, because it's closest to the number. And so you get the cube root of 4. And then do F of that answer. What that means is look at your F function, which is this, and plug in cube root of 4 where X is. And you never need to rationalize a cubic, so that's your answer. Yeah, the cube root of 4 plus 7 for your denominator. Okay, so that's for A. Cube root and third root mean the same thing. Now for G circle f of 2, we want to do f of 2 first. So 18 over 2 plus 7. Do your 2 plus 7 first and you get 9. 18 divided by 9 is 2. And then you do G of that answer. So you have G of 2 is the cube root of 2. And there's nothing else to do for that. So cube root of 2. Then for this one, we're doing f circle f of 1. So do f of 1 first. You get 18 over 1 plus 7. It's 18 over 8, which is 9/4. Both of those are divisible by 2. 18 divided by 2 is 9. 8 divided by 2 is 4. Then you do f of 9/4. So that gives us 18 over 9/4 plus 7. Now this looks a little ugly, but you can type it in the calculator and it will reduce your fraction for you. So 18 divide by parentheses. Then you put your 9/4 and then plus 7. Enter. 18 over 9/4 plus 7 gives you 72 on top and 37 on bottom. That's your answer. Yeah, make sure your parentheses are right when you're typing it on, and then it removes them to look like that. Then this one is G of 0. So we get the cube root of 0, which is 0, and same answer again for G of 0. So that's just 0. Okay, that's number 9. Number 10, find a positive angle less than 360. So you basically want to add 360 repeatedly until you get to the right spot. Negative 970 plus 360 gives you negative 610. It's still negative, so you got to keep on adding. So plus 360 gives you negative 250. And add 360 again. Gives you 110. That's your answer. It's the first time we hit something positive. Okay, that's going to be our stopping point for today.